Hi everyone, welcome to mathworld. This video is to discuss Cambridge International AS and A-Level Mathematics Paper 4, which is the Mechanics, for February-March 2023, and the code is 9709/42. Okay, so let's move on to question number 1. For question number 1, a crate of mass 200 kg is being pulled at constant speed along horizontal ground by a horizontal rope attached to a winch. The winch is working at a constant rate of 4.5 kilowatt, and there is a constant resistance to the motion of the crate of magnitude 600 newtons. So now, A, find the time that it takes for the crate to move a distance of 15 meters. So we need to find what is the time. Okay, basically, when I draw the diagram, let's say this is a crate, right? And it's pulled at a constant speed by a horizontal rope. Let's say this is the rope and this is a winch. And now, from here, we know that constant speed means that the A equals to 0. Okay, and then the mass for this crate is 200 kilograms. And then the resistance, there's a constant resistance of 600 newtons of the crate. So here is 600 newtons. Alright, so, and then you are given 4.5 kilowatts as well. So this 4.5 kilowatts is basically power. Okay, so now we know that power equals to FV, right? Whereby the F is a driving force. Then from here, it is also same as Fs over T, because now we need to find the time. Okay, therefore, I refer to Fs over T for the power. So now the power is 4.5 kilowatt. That means this is 4.5 times 10 power 3. My F here, okay, my F is basically, now, to get the F or the driving force, what I need to do is, I need to refer to the crate with the F, or you can just write driving force, and then this is the 600 Newton. Then now, according to Y, F equals to ma, Newton's second law. So now, F minus 600 equals to the ma. So m is 200, the a is 0 because of the constant speed. Therefore, from here I know that F is 600. Okay, so that means I will be replacing the F over here by 600. Now the S is a distance. Okay, it's mentioned distance of 15 meters. So 15, then over time. Alright, then from here, your T, you just move up the T and move down the power. Okay, so just cross multiply. Then I will get 600 times 1.5, sorry, times 15. Okay, because the distance is 15 meters, then over 4.5 times 10 power 3. So at last, you will be getting 2 seconds. So that's the time for the crate to move a distance of 15 meters. Now, the rope breaks after the crate has moved 15 meters. B, find the time taken after the rope breaks for the crate to come to rest. Okay, so now, when the roof breaks means that we will just consider the crate here. Okay, so now this is a crate, and then it moves with acceleration of A, and then we have the resistance with magnitude 600. Remember, your M is still 200 kilograms. Okay, so when F equals to ma, which is Newton's second law. Now here, since the rope breaks, means that now we only have one force, which is a resistance force. Now, and then the crate will move to the right side. Okay, so then the 600 newtons is in the opposite direction of the A. That means I will write negative 600 for the F, then equals to 200 for the M, okay, 200 kg, and then the A is unknown. So from here, your A is going to be negative 600 divided by 200, and I will get negative 3 meter per second squared. Okay, now we need to find the time when the crash comes to rest. So when comes to rest means that V equals to 0. Okay, then now what is the time? So from here, since we have found the A, then I will just use V equals to U plus AT formula. So the V is 0. Now the U, right? The U is going to be 15 over 2. Okay, plus the A is going to be minus 3. Because here, A equals minus 3. And then now, I will get times 3. So from here, 15 over 2 equals to 3t. Therefore, the t is going to be, okay, just move down the 3. So I will be getting 15 over 6, which is 2.5 seconds. Okay, so that's the solution of the time. Now, for question number 2, a particle P is projected vertically upwards from the horizontal ground with speed 15 meter per second. A, find the speed of P when it is 10 meters above the ground. Okay, let's say for example, this is the P, this is the ground, right? It is projected with U equals to 15 meter per second, and then this is 10 meters. What is the speed over here? What is the VP? Okay, so now from here, since you are given a U, M, and you need to find V, and we know that the particle is projected upwards, means that your A is going to be negative 10, right? So A is negative 10 meter per second squared. Then I can use V squared equals to U squared plus 2AS. Alright, so now the V is basically do not know, which is our VP, right? VP squared. The U is 15, so 15 squared plus 2. The A is going to be negative 10, and then the S is 10. So then from here, you will be getting 225 minus 200, and then I will get 25. So this 25 is a V squared. That means now I will say VP is going to be 5 meter per second. Okay, now at the same instance that P is projected, a second particle Q is dropped from the height of 18 meters above the ground in the same vertical line as P. Find the height above the ground at which the two particles collide. Okay, now this is a diagram. Let's say this is a P, okay, projected upwards, and then at the same time the Q is dropped. Okay, and we know that total here is 18 meters. Alright, let's say for example, okay, this is drop. That means a U equals to 0, UQ. Alright, now you need to find the height above the ground at which the two particles collide. So let's say for example, the particle P has traveled up for SP distance. Okay, and then we know that the total distance between P and Q is 18, which means the Q will be traveled 18 minus SP distance. Then they will collide. Right? So from here, to solve the S, right, you need to find what is the height above the ground, which means what is the SP. What is the SP? Okay, so from here, I will consider two particles differently. For the P, my SP is UT plus half AT squared. I'm using this formula. S equals to UT plus half AT squared. Okay, then my SP is going to be, now, your UT. Let's look at the previous question. Initially, your UP is 15. So from here, I will write UP is 15. Okay, so it will be 15T, because I'm not sure how long time it will go to SP. It has been traveled to SP distance. Then plus half. Now since the P is projected outwards, means that your A is going to be negative 10 meter per second squared. So here I will write negative 10, then T squared. And then when I simplify, I will get 15T. Half times negative 10 is basically negative 5, then T squared. This is my SP. And let this be first equation. Because now you need to find the height, right, which is the SP. So now my SP actually depends on the T. So I need to find another equation from the particle Q and then solve for the T values. After I have found the T, then I can find the SP. So now let's consider the particle Q. So when you consider the particle Q, at first the Q is dropped, right? So use the same formula, S equals to UT plus half AT squared. My U is 0. So this is UQT plus half AT squared. So my SQ is basically 18 minus SP. So 18 minus SP, my U is 0. UQ is 0 because it's dropped, plus half my A. Okay, since it is dropped due to the gravitational acceleration, that means your A is going to be 10, positive 10. Alright, because upwards is negative, downwards will be positive. So here is going to be 10, then T squared. Now I will get 18 minus SP equals to 5T squared. Alright, this is my second equation. Now I will substitute first equation into second equation because I have the SP there. So first into second, I will get 18 minus, my SP will be replaced by the right hand side of the first equation. So it will be 15T minus 5T squared. That is my SP. Then right hand side equals to 5T squared. Okay, then now I will open the brackets. So it will be 18 minus 15T plus 5T squared, that equals to 5T squared. Then the 5T squared from both sides can be cancelled off. Then I will get 18 minus 15T equals to 0. That means the 15T equals to 18, which is T equals to 18 over 15. Then I will get 6 over 5. Okay, which means when T equals to 6 over 5 seconds, the P and Q will collide, right? So now I need to find the distance or the height above the ground, alright, which means that is the SP. What is our SP right now? So from the first equation, my SP is going to be 15T. So the T will be replaced by 6 over 5 minus 5T squared. So at last, I will be getting 10.8 meters. So which means that is the height above the ground. So height above the ground when P and Q collide equals to 10.8 meters. Okay, so that's the solution for this question. Now, question number 3. A particle moves in a straight line starting from rest. Starting from rest means when T equals to 0, the V equals to 0. Now, from a point O, the acceleration of the particle after T seconds is given by A equals to 4 times T to the power half. So now A find the speed of the particle when T equals to 9. So we know that the velocity, because you are given the acceleration, okay? So velocity equals to integration of A dt. The A is acceleration. So now I'm going to integrate. Before you get the speed, you have to get the acceleration first, because the speed is the magnitude of the acceleration, or the scalar of the the speed is the scalar of the velocity. Okay, so here is 4t to the power half dt. Now, when you need to integrate, okay, so now you have to refer to a x degree n dx. And since the a is constant, then you can just take out the a and write x degree n. And then when you integrate, it will be x degree n plus 1 over n plus 1, then plus c. Okay, provided the n is not minus 1. Now, when I substitute into this formula, I will have 4, then t to the power of 3 over 2, because half plus 1 is 3 over 2, then divided by 3 over 2, then plus c. So now I will have to simplify 4 divided by 3 over 2. So that is 8 over 3. Alright, that is our v, but you have the c there. So now use the concept starting from rest. Means that when t equals to 0, your v equals to 0. Which means now 0 equals to c. Then I will get the v, which is just by replacing the c equals to 0. So this is my expression for v, which is a speed, or I would say that this is a velocity. So now you need to find the speed when the t equals to 9. So you substitute t equals to 9 first. If it is negative, just put the modulus. Otherwise, that will be your speed. Okay, you can say that is a speed. So now from here, when you simplify, it will be 72 meter per second. So I will just write speed is 72 meter per second. Okay, that's the solution for A. Now B, find the time after leaving O at which a speed in meters per second and the distance traveled are numerically equal. Okay, so now because of the distance will be equal to speed, alright, numerically equal means that in terms of magnitude it will be the same. So now I need to find the expression for distance. So before we get the distance, we have to get the displacements first. So our displacement is integration of velocity with respect to time. So now velocity already found just now. This is our velocity expression. So now I'm going to integrate this expression, which is integrate h over 3 t to the power of 3 over 2 dt. Okay, again use the same formula. You need to add 1 to the existing degree. Remain the h over 3 and add 1 to the existing degree. So it becomes 3 over 2 plus 1, you get 5 over 2. Then divided by 5 over 2, after that you plus c. This is our expression for s. And then now, when you need to simplify h over 3 divided by 5 over 2, right, then you will be getting 16 over 15, then t to the power of 5 over 2 plus c. So that's your expression. And now again, from here we know that because the particle moves starting from rest from a point O, which means when t equals to 0, your s will be 0 because your a is the acceleration at the time t after leaving O. Alright, so now I will write t equals to 0, s equals to 0. Therefore, c equals to 0. Okay, then from here, I will get s equals to 16 over 15 times t to the power 5 over 2. So this is the expression for the displacement. Now, we know that distance is the scalar of displacement because displacement is the vector. So now it's given that the speed and the distance are numerically equal. So now I will just copy this v. I will just write v equals to s. Alright, because they are numerically equal. So my v is h over 3 t to the power of 3 over 2, whereby from here, okay, then my s is going to be 16 over 15 times t to the power of 5 over 2. Okay, so now from here I will just move the right side to the left hand side. So 8 over 3 t to the power of 3 over 2 minus 16 over 15 times t to the power of 5 over 2, that equals to 0. Then from here I will factorize 16 over 15. At the same time, the smaller degree of the t is 3 over 2. So I will factorize this. Then now you will be getting first term is 5 over 2. Okay. So when you factorize 16 over 15 from 8 over 3, it's basically 8 over 3 divided by 16 over 15. Then you will be getting 5 over 2 here. Then now, since I have factorized t to the power of 3 over 2, and now here you get t to the power of 5 over 2, means that you still have degree 1 for the t. Okay, so you are getting this now. If you have product of two terms equals to 0, means that one of them must be 0. So when I let the first one be 0, my t is going to be 0. And if I let my second one be 0, my t is going to be 5/2. Okay, so obviously when t equals to 0, the distance will be 0, which is the starting, the initial condition. Okay, so then now the question asks for time after leaving O. Therefore, we cannot accept t0. Alright, the t must be 5/2 seconds. So that's the solution for this question. Now for question number 4, a toy railway locomotive of mass 0.8 kilogram is towing a truck of mass 0.4 kilogram on a straight horizontal track at a constant speed of 2 meters per second. Now, there is a constant resistance force of magnitude 0.2 Newton on the locomotive, but no resistance force on the truck. There is a light, rigid horizontal coupling connecting the locomotive and the truck. A. State the tension in the coupling. Okay, now the diagram is like this. Let's say this is the truck, right? So no, this is the locomotive because it is towing a truck. So let's say this is the truck, right? The truck is 0.4 kilogram and this is 0.8 kilogram. Now, okay, so let's say moving to the right side, constant will be 0 because of the the acceleration will be 0 because of the constant speed of 2 meter per second. So the U is 2 meter per second. Now, there is a constant resistance force of 0.2 on the locomotive, which means here I will have 0.2 Newton. Okay, and now there will be a driving force act on the locomotive. Now, there is a light rigid coupling connecting the locomotive and truck. Means that here you will have tension. Okay, now A, state the tension in the coupling. So for this, I can just say I refer to the truck. Okay, truck. So this is a truck. I use F equals to ma. Okay, which is Newton's second law. So now for the truck, when you refer to here, just this part, truck. Alright, so we only have one tension here. So that means F is tension. Then now M is 0.4 because we just consider the truck. Then the A is going to be 0 because of the constant speed. So from here, my T is going to be 0 Newton. That is the tension in the coupling. Now you can refer to truck, or you can refer to locomotive, or you can refer to whole system. So we have three methods to solve the tension. Now B, find the power produced by the locomotive's engine. So now I need to concentrate on locomotive's engine right now. Okay, so now the power is F times V, or I would say that it is D times V. So but then I do not know what is my D here. Okay, what is the driving force? Do not know. So therefore I have to consider the whole system, right, in order to get the D. So when I consider whole system, again using Newton's second law, then now when you consider the whole system means that you will check. You have two choices. Either you use the whole system or you can just refer to the locomotive. Okay? So from here, when I consider whole system, basically the I will not consider the T anymore because it is balanced off. Okay, one pointing left, one pointing right. So I will just consider D 0.2. That's it, right? So that will be my F. So my F is going to be D minus 0.2. then equals to the M. Since this is whole system, means that it will be the total mass. Then I will get 0.4 plus 0.8. Okay, then the A is still 0 because it's mentioned that constant speed. So from here, my D is going to be 0.2 Newton. Okay, now to get the power, right, power, so I will get P equals to dV. So because when you refer to the locomotives, right, just this part, locomotives, right? So now you are considering the locomotive's engine. So now P equals to dV. Therefore, from here, I will get equals to 0.2 times the V. V is given in the question, which is a constant speed, which is 2 in the question. Then you'll be getting 0.4 watt. So that's the power produced by the locomotive's engine. Now, the power produced by the locomotive's engine is now changed to 1.2, just now 0.4. Now see, find the magnitude of the tension in the coupling at the instant that the locomotive begins to accelerate. So, for the part C, right, since your power has been changed, then I'm no longer using the previous D, the driving force. So now I have to calculate what is my D, driving force. Okay, so then now the power is 1.2 watt, then the D is unknown, and then the V remains, which is 2. Then from here, my D is 1.2 divided by 2, then you will be getting 0.6 Newton. Now again, okay, before you get the magnitude of tension, now I have to consider the Newton's second law. Okay, so I will write F equals to ma. Now you need to get the tension. Okay, so when I refer back to the diagram, I will refer to the truck. So truck is here. This is a truck. Okay, after that I will refer to the whole system. So my truck remains T, F is T, then the M is 0.4, A is unknown. Okay, so now the truck I will get T equals to 0.4 A. This is the first equation. Then now I will consider whole system. So when I consider whole system, I will just consider the D. Okay, look at here. I will consider the D and then the 0.2 as my force, right? Then I have to find the resultant force. The T will be cancelled off because both will be balanced. It will be balanced out. So it means that my F here will be D minus 0.2. The driving force minus the resistance force. Okay, equals to, now system, the mass is 1.2 based on here. This is 1.2 total mass. So 1.2 A. Okay, then now I have found the D just now. The D is 0.6, so I will replace 0.6 minus 0.2 equals to 1.2 A. Then from here, okay, I will get 0.4 equals to 1.2 A, and at last my A is going to be 0.4 divided by 1.2. Then you will get 1 over 3. Once you found the 1 over 3, let's say this is the second equation, I will substitute back into the first equation because now you need to get the tension, right? So second into first, the tension is going to be 0.4 times A, means times 1 over 3. Then at last, you will be getting 2 over 15 Newton. So that is the tension. Okay, so now for question number 5, you are given the diagram here. A diagram shows the block D, this is the block D, of mass 100 kilograms supported by 2 sloping struts, AD and BD. So here AB and BD. Each attach an at an angle of 45 degrees to fix points A and B respectively on the horizontal floor. The block is also held in place with a vertical rope CD. So CD with the tension of 500 newtons. Now, okay, the C is on the horizontal ceiling. The tension in the rope CD is 500 newtons and the block rests in equilibrium. Means that not moving. Now A, find the magnitude of the force in each of the struts AD and BD. Okay, so from here, I will consider two tensions. So this is TA and this is TB. Okay, so now I will resolve the forces horizontally and vertically. So now, when you refer to here, okay, this is 45 degrees. So from the zigzag, we know that this is 45 degrees. Here is also 45 degrees. Alright? Then from here, where I resolve horizontally, my TB resolve. Okay, and don't forget the 100 kilograms has the weight of 100 G. Okay, so now I resolve the TB horizontally, then it will be cos 45. You can write sine 45, no problem, because we know that this is a right angle triangle. So if here 45, this is also 45, right? So cos and sine 45 will be the same. Then I will write TB cos 45 degrees equals to TA cos 45 degrees, which means my TA is same as TB. Okay, then next I need to get the actual values of T and TB by resolving the forces vertically. So when vertically, this is going to be resolved down, here resolved down. And I know that here is 45 degrees. This is also 45. Okay, and together with the 100 grams, 100 G. So now I will have 3 down, what is that called? The downwards forces and 1 upward force, which is 500 newtons. So I label arrow up. Vertically up means that the forces pointing upwards will be positive. Therefore, I will get 500 newtons equals to these 3 forces, okay, after you have resolved them. So it will be 500 equals to 100 G plus TA cos 45 plus TB cos 45, because you resolve vertically. Okay, so here it will be 100 G plus TA cos 45 degrees plus TB cos 45 degrees. Or you can write TA sine 45 degrees plus TB sine 45 degrees. They will be the same. Okay, so from here, I will get 500 equals to 100 times 10, because the G is 10, plus, okay, this TA cos 45 degrees is 1 over square root 2. Then now TB is same as TA. That means these two terms are the same. So I will just times 2. Okay. So now next step is just to move this to the other side. So 100 times 10, it will be 1000 on the right hand side. The 1000 move to the left hand side becomes minus 1000. Then 500 minus 1000 is going to be negative 500. Then for the right hand side, the last term is going to be 2 over square root 2 TA. Okay, so from here, my TA is going to be negative 500 times square root 2 over 2. So the 500 divided by 2, it will be 250. So negative 250 square root 2. That is my TA. Okay, and then my TB will be the same as TA. That means it is also 2 square root 2, sorry, negative 250 square root 2. Okay, that's my TA and TB. But then the question says find the magnitude of the force. So it means that now the magnitude of force in each of the struts AD and BD equals to 250 square root 2. Okay, because now we will just refer to the magnitude. We can just ignore the minus sign. Okay, now a horizontal force of magnitude F Newton is applied to the block in the direction parallel to AB. So let's see where is the AB. AB is a horizontal, means now you will have one force here, which is the F Newton. Okay, find the value of F. Find the value of F for which the magnitude of the force in strut AD is 0. So means that the strut AD is TA. So you need to find the Fn such that TA equals to 0. Okay, so for this case, I will draw the diagram. Just concentrate on the mass. Here is 100 gram, 100 G. Then this is the 500 Newton. Okay, which is here, 500 Newton. Instead of this F, I will just draw it over here. Okay, so now my F is towards right hand side. Then, and it's mentioned that the force in the AD, the struts AD is 0, means that now I will not draw the TA. So I will draw TB. This is my TB. And don't forget, here is 45 degrees. Okay, so now I have to resolve horizontally and vertically. So when I resolve horizontally, right, so then this TB resolve to the right side. That means you will have two forces pointing right hand side, and there's no force pointing right hand side. So which means now F plus TB cos 45 degrees equals to 0. Okay, then my TB cos 45 degrees equals to negative F. Now, when I resolve vertically, going up is positive, which means now I will have to resolve my TB downwards, and then I will have two forces downwards and one forces upwards. One force upwards means that now I will get 500 equals to 100 G plus TB cos 45 degrees. Okay. So here plus TB cos 45 degrees. So when you resolve using the own angle, right, that means we are using cos. Okay, I will say that here is 45 degrees, this is also 45 degrees, so that it will be 90 degrees, which is a right angle. Then now from here, I will have 500. Now, we need to find F, but we know that the F is actually TB cos 45. Alright, so from here, I will just replace. So probably I will just get equals to 100 times 10 plus, okay, so now my TB cos 45 degrees is going to be minus F, because we need to find F. So I will write minus F. Okay, so now you will be getting 500 equals to 1000 minus F. So to get the F, the minus F move to left side, the 500 move to the right side. So then I will get F equals to 500 newtons. Okay, or just write F equals to 500 because the force is Fn. So that's the solution for parts B. Okay, now number 6, you are given a diagram. A block B of mass 2 kilograms, that means here is 2G, lies on the rough inclined plane sloping at 30 degrees to the horizontal. This is the angle, 30 degrees. A light rope inclined at an angle of 20 degrees above a line of greater slope. So here is the 20 degrees. Is attached to B. The tension in the rope is T and T newtons. There is a frictional force of Fn acting on B. Okay, this is the Fn. The coefficient for friction between B and the plane is mu. Now, from here, we need to get the R, okay, which is a normal reaction. Now, it's given that F equals to 5. Then that's the acceleration of B up the plane is 1.2. So here going up is 1.2 meter per second squared. That is our acceleration. Find the value of T. So for this case, I need to resolve along the plane. Okay, so I resolve the forces along the plane. So what I will get is what I'm getting is I resolve the T and then resolve this 2G. Okay, so for information, if here is 30 degrees, now here is 30 degrees, that means, right, let me draw again. This is going to be 30 degrees. Okay, so now I need to resolve my 2G to this direction, and I'm using the angle beside that. Right, that means you are going to use sine. Okay, so here basically I have 3 forces where I resolve the forces along the plane. That means I will be getting T cos 20 because I resolve the T using the angle of 20 degrees. So T cos 20 degrees, alright, then minus, and you are given that the acceleration is 1.2. So basically I'm substituting the formulas, I'm substituting the forces into the Newton's second law. Alright, so F equals to ma because the particle is moving. So now, since it's moving up, that means the Tn will be positive. So that's why when you resolve the Tn using 20 degrees, therefore it will be T cos 20 degrees. And then the F and the 2G sine 30 degrees because when I resolve the 2G to the to the direction which is along the plane, I'm using the alternate angle here. So both are opposite, are in the opposite direction as in the A. Okay, therefore it will be negative. So it should be negative. Then I will get 2G sine 30 degrees plus F. Then equals to MA. My M is 2. And then the A is given 1.2. Okay. So now, from here, I need to get what is my F. F is the frictional force and is given that it is 5. Alright, so just replace. Then I will get T cos 20 degrees minus 2G, G is 10, sine 30 degrees is half. And then the F is going to be 5. Then 2 times 1.2, it will be 2.4. Okay, so now you can simplify. So the 2.5 cancel. I will get 15 in the bracket. Therefore, my T cos 20 degrees is going to be 2.4. There's a minus outside, now becomes plus. So plus 15. Okay, and you'll be getting 17.4. That is a T cos 20 degrees. Now, in order to get T, just move the cos 20 degrees to the other side. So it will be 17.4 divided by cos 20 degrees. Then you will be getting 18.5167 and round up to 3 significant figures, that will be 18.5. Right, now part 2, find the value of mu. So we know that F equals to mu R, right? So now before that I have to resolve the forces so that they are perpendicular to the plane. So now when perpendicular to the plane, I will have R, then I resolve the T. So when I resolve the T, it is not using its own angle, but I'm using 20 degrees, therefore it will be sine. And then this 2g will be resolved so that it is in the direction of perpendicular to the plane. But now I'm using 30 degrees, therefore it will be cos. Okay, so now I will write r plus t sine 20 degrees equals to 2g cos 30 degrees. So because your forces are in the direction of perpendicular to the plane, so we don't consider the A, right? Because your A is along the plane. So that's why I'm getting this now. Then now my R is going to be 2g, g is 10, cos 30 degrees is square root 3 over 2, then minus t sine 20 degrees. So the t I have found just now. Okay, I will use 18.5167 for my t. Then sine 20 degrees. And now at the same time, okay, then when you calculate this, you will be getting 10.9874. Now, we know that the F equals to mu R, right? And the F is 5. So, F equals to mu R, 5 equals to mu times 10.9874. Therefore, your mu is the division of these two values. Then at last, you will be getting 0.455. So that's the mu value, the coefficient of friction. Okay? Now, part B, it is given instead that the mu is 0.8 and t equals to 15. Determine whether B will move up the plane. Okay, so now, I have to resolve perpendicularly. Okay, so in terms of formula, it will be no change. Use back this. So I will write R equal R plus T sine 20 degrees is 2G cos 30 degrees. Okay, but now your T has been changed to 15. So your R is going to be 2 times 10 times square root 3 over 2 minus 15 sine 20 degrees. Therefore, you will be getting 12.19. That's the R. Okay, now I need to find out what is my A. Okay, because initially your A is 1.2 meter per second squared. So to determine whether the B will move up or not, then I have to check the A. Now again, I refer to the forces that are in the direction of the plane. So means now, okay, so when you refer back to here, almost the same, but you cannot get the A, cannot use back this A, you have to recount the A. Okay, and this F you have to recount. Alright, so then the rest you can just copy. So I will write T cos 20 degrees minus 2G sine 30 degrees. Okay, plus the F here. Okay, the F here I will change to mu R. Okay, because this is the frictional force. And then now I will write mu 0.8, and then this is the R, 12.19. Okay, then equals to 2A. Now, the T is given just now. Okay, T is 15. Probably here I will just write mu R, otherwise you will confuse later on where to get the values. So here mu R. Alright, so now next step is just to replace the values. So T is given 15, so 15 cos 20 degrees minus, this is 2 times 10 times half, plus the mu is 0.8, the R already found, 12.19, then equals to 2A. Okay, so when you calculate the values on the left hand side, after I simplify these two terms, you will be getting a negative value. So the value is negative 5.6566 on the left side, and right side is 2a. Then from here, my a is going to be negative 5.6566 divided by 2, and you will get negative 2.83 meter per second squared. Okay, so now you refer back. When the a is 1.2 meter per second squared, it goes up. So now your a is negative, means that it goes down. Okay, and come back to the question. The question says whether b will move up the plane. So the answer is no. All right, because your a is less than 0. So b does not move up the plane. It will go down because this is negative. All right. Now next question, question number 7. The diagram shows a smooth track which lies in a vertical plane. The section AB is a quarter circle with radius 1.8 meter with center O. That means here is 1.8 meter. Here is also 1.8 meters. Now the section BC is horizontal straight line with length 7 meters, and OB is perpendicular to BC. Okay, OB is perpendicular to BC. The section CFE is a straight line inclined at an angle of theta degrees above the horizontal. So it's here. Now a particle P of mass 0.5 kilogram is released from rest at A, which means this is the P. Okay, so release means U equals to 0, UP equals to 0. Now, P collides with a particle Q of mass 0.1 kilogram, which is at rest at P. So, there is a particle here. This is the particle Q. Okay, and then it is 0.1 kg. So, MQ is 0.1 kg and it is at rest. So, the UQ is 0. So, the MP is 0.5 kg. Alright, now immediately after the collision, the speed of P is 4 meter per second. So it means that after it collides with the Q, then the P, okay, this is the P, VP is 4 meter per second. Okay, this is the Q. This is the Q. Okay, now in the direction BC, so VP is moving to the right side. You should assume P is moving horizontally when it collides with Q. Okay, now A, show that the speed of Q immediately after the collision is 10 meter per second. Okay, so obviously, now we have to consider the conservation of energy first, because I'm not sure. I do not know what is the P, right? I'm not sure what is the P, the what is that called, the the speed of the P before it collide the B. Okay, so now for the P itself, I need to use conservation of energy, because I only know the initial velocity, initial speed of the P. So from here, at first, the particle P has gravitational potential energy, and then it has turns into the kinetic energy. Right? So now from here, I will say that mgh equals to half mv squared. Alright, loss of P equals to gain in KE. So now for the P, the M is 0.5. Here is 0.5. The G is 10. The H, okay, so now the H is 1.8. Right, this is the vertical distance. So 1.8. then half, the m is 0.5, then v do not know. I will let it be vp squared. So from here, the 0.5 will be cancelled off. Okay, then the half move up, it will be 20 times 1.8 equals to vp squared. Therefore, my vp squared is basically 36, and then my vp is 6 meter per second. Means that when it reaches the B before it collides with the particle Q, so the speed is 6. Okay, now the question is finding the speed of Q immediately after the collision, or show that the speed is 10 meter per second immediately after the collision. So now for this case, I need to use conservation of moment of linear momentum. Alright, then I will write mp/vp plus mq/uq, because at first the q is at rest, then equals to mp/v1p. Okay, so v1p means that here I have to write v1p, cannot be vp anymore. Okay, then it will be plus mq/vq. So I need to show vq is 10. So now mp is 0.5, the vp is 6, plus the mq is 0.1 because it's 0.1 kg. Then the uq is 0 because at first it is at rest. Now mp is 0.5. The v1p is given in the question, which is 4. So here it will be 4 plus 0.1 times vq. So the left hand side, 0.5 times 3 is basically 3. Sorry, 0.5 times 6 is basically 3. Then 0.5 times 4 is 2. Okay, plus 0.1 VQ. So now 0.1 VQ is 3 minus 2, which is 1. Therefore, my VQ is 1 divided by 0.1, and you are getting 10 meter per second. So this is the speed of Q right after the collision. Now, when Q reaches C, it collides with a particle R of mass 0.4 kilogram, which is at rest at C. So here we have another particle. Okay, so it means that the Q already reaches C. This is your Q. And then you have another particle here. This is the R. Okay, so UR equals to 0 because it is at rest. And then from here, the R is 0.4 kilogram. So my MR is 0.4 kilograms. So I will write here MR is 0.4 kilograms. Okay, now two particles collide. The combined particle comes instantaneously to rest at F. Means that, okay, after these two combine together, it will go up to F. Okay, then at rest means that the V will be 0. You should assume there is no instantaneous change in speed as the combined particle leaves C, nor when it passes through C again as it returns down the slope. Okay, so rest a while, then after that goes down and come back to C. Okay, now given that the distance CF is 0.4 meters, find the theta value. So it's given in the diagram. Okay, CF here, this is 0.4 meters. Okay, now we need to get what is the theta. So from here, I need to check the speed. What is the speed when they're combined together? Alright, so firstly, I have to find the speed when they're combined together. Later on, I need to use the conservation of energy to get the theta here. So now, I will start with the conservation of linear momentum. Then I will write MQ VQ plus MRUR equals to, since they're collides, means that they will combine together and move with speed v. So the MQVQ. So just now MQ is 0.1. The VQ is basically 10. Okay, from the previous calculation. So 0.1 times 10. The MR is 0.4 from the question here. Then it is at rest, means that the U equals to 0. So 0.4 times 0. The MQ plus MR is going to be 0.1 plus 0.4 together with the V. So from here, left hand side 0.1 times 10 is 1. Then 0.4 times 0 is 0. Then the right hand side is going to be 0.5 V. Therefore, your V is 1 over 0.5. Then I will get 2 meter per second. Which means after they collides, means that they combine together, the V is 2. Okay, they move with 2 meter per second up to the F here. After that, rest a while, then goes down. So now, when they go up, right, means that now it will have the the PE, gravitational potential energy. Okay, so from here, I'm going to use that to solve. So now I will start with conservation of energy. So my mgh will be half mv squared. Okay, now where is my mgh? So the m here is the combined mass. Okay, because both of them collides. Collides means combine together. So now your m here is 0.5. Okay, so I will get 0.5. The g is 10. Now this h is the vertical distance. So when you look at the triangle here, we know that here is going to be theta. Okay, and this is a C, here is a F, and I know that this is 0.4 meters. Now, if you need to get the vertical distance, we know that vertical distance is question mark, right? That is the opposite side. And then this 0.4 is the hypotenuse. So if you have opposite and hypotenuse, then it should be opposite and hypotenuse should be sine. Alright, so sine theta is going to be question mark divided by 0.4. So now your question mark is 0.4 sine theta. That will be my height. This is also my h. I will say h. Right? So then I will get 0.4 sine theta. That equals to half mv squared. Half, the m is the total m, which is 0.5. Okay, because two particles combine together, therefore it is 0.5. And then the v is going to be 2 squared, because we have found here there will be moving up with 2 meter per second. So from here, 0.5 times 10. Okay, no need to times because I can cancel 0.5 from both sides. And now I will get 0.5 times 0.4 is going to be 4. Wait, I cancel wrongly. Sorry. I should cancel the 0.5. Okay, I should cancel the 0.5. So 10 times 0.4 is 4. So it will be 4 sine theta equals to half times 2 squared. 2 squared is 4. So half times 4, it will be 2. So from here, my sine theta is 2 over 4, which is half. Which means my theta is inverse sine half. Then it will be 30 degrees. Okay, so that is the theta value. And now find the distance B at which P collides with the find the distance from B, okay, at which P collides with the combined particle. So for your information, alright, so here BC, this is B, here is C. Then moving up, here is 0.4 meters. Okay, so distance from B, and we know that here is going to be 7. Let me see how many. What's the distance? The distance is 7 meters. Okay, so now I need to find the B, because from here we know that the two particles combine together. Okay, combine together, then it will go down. When both of them go down, okay, it's here. Don't forget the P. Okay, the P all the while is moving to the right side. Okay, so P moves to the right side, the Q also moves to the right side. So now you need to find what is the distance from the B when both of them collide. Means that this is the P, this will be the both particles. Okay, so I need to find from B, what is the distance over here. So now, therefore from here, I need to count when the Q, okay, when the Q, this is a Q and this is a Q. When the Q reaches here, right, how long time it takes for the Q to reach C. Because at first the Q is at the B. Then at the same time, your P, once it collides with the Q, this is a Q, the P will be moving to the right side. But then the speed is different. Okay, so now I have to find how much or what is the distance for the P to travel when the Q reaches C first. Okay, so for the Q, S equals to VT. So the S is 7 because it has the points Q. Okay, this is a points Q. Points Q already reaches C. So I need to find how much time it needs to reach C from B. So the V is 10. Okay, then the T is time, because we know that at first your Q, right, after the collision with the P, it moves with 10 meters per second. So that's why here it is 10 meters per second. This is the VQ. Alright, so means that the T is going to be 7 over 10, which is 0.7 seconds. So when 0.7 seconds, the Q already reaches C. And now I need to find for my P. Okay, for my P, what is the distance? So let's say this is a distance 1, it will be VT. So here, the V for the P, once it collides with the Q, alright, in the questions is mentioned that the speed is 4. Look at here, the speed is 4. So now I know that I'm going to write this is VP 4T. Okay, so the T is 0.7 because both are moving. So it means that the P has moved for 2.8 meters. So which means here is the P. When the Q reaches C, this is only 2.8 meters. Okay, then now the Q collides with R. This is the R, and then both collides and go up. So when it goes up, I need to find what is the time for both combined particles to reach the F here. Alright, so now for this, I need to get my A first. So I will draw just this part. Okay, here is the data. The data already found just now, that is 30 degrees. So what I need to do here is, I will just draw the diagram. So this is the F, here is the C. Okay, this is 30 degrees. And then here is 0.4 meters. And now, when it reaches here, the combined particles, the weight is 0.5 g. Okay, and then now from here, I need to get my A. What is the acceleration? So F equals to ma, right? So my F, because look at here. Now, when I resolve this 0.5 along the plane, right? it should be negative because my force will goes down. Okay, will go down. Therefore, it will be negative 0.5 G. And for your information, here is going to be 30 degrees. Right, 30 degrees. So I am not using my own angle. I'm using 30 degrees. Therefore, it will be sine. So this is sine 30 degrees equals to MA. So my M is 0.5. The A is unknown. So from here, the 0.5 will be cancelled off from both sides. Therefore, you can find the A. Means that your A is basically negative 10 times half. Because sine 30 is half. Then you are getting negative 5 meter per second squared. So now your A is negative 5. Okay. So my A, I treat A be positive going up. So means that it will go down. A equals to 5 meter per second squared. Now, based on this, I need to find my time. How long time it takes for the particle to reach C to F. Okay, so now for the C to F, so for C to F, S equals to UT plus half AT squared. So then the S is 0.4. So 0.4 equals to the U. Okay, the U is basically 2 because from the previous calculation we know that both of them, see, both of the particle moving with V. V is the 2. So therefore, I will get U equals to 2 now. So 2, T is unknown, plus half, the A is negative 5. So negative 5, then T squared. So from here, I change all to fractions. So 0.4, it will be 2 over 5. Then equals to 2t minus 5 over 2t squared. And then I times the whole equation by 10. It will be 4 equals to 20t minus 25t squared. And now I rearrange this to get the quadratic equation. That is 25t squared. I move all the terms to the right side. Minus 20t plus 4 equals to 0. Okay, then from here, this quadratic equation can be factorized into 5t minus 2 squared equals to 0, which means my 5t minus 2 equals to 0, t equals to 2 over 5. This means, okay, we need 0.4 seconds for the combined particle to move from C to F. Okay, now we know that once they reach F, they will stop a while and then go down. So go down also go down with has traveled for the distance of 0.4 meters, which means the time will be the same as well. So FC will be 0.4 seconds. Okay, so from F to C, the T is 0.4 seconds as well. So it means that when C to F, then F to C, this is for combined particle. The time is 0.4 plus 0.4, which is 0.8. Okay, 0.8 seconds. So now I need to find out during this 0.8 seconds, what is the distance that has been traveled by the particle P. So now for particle P, let it be S2. That is the VT. Okay, so now it will be V. What is the V? Let's check. The V remains the same, 4. Then the T is 0.8. Then I will be getting 3.2 meters. So which means from here, right, for the particle P, or I will say that I want to check. Okay, let's see the question. Find the distance from B at which the P collides with the combined particle. So what I need to do here is I refer to the particle Q. Okay, so I refer to particle Q from B to C, then to F to C. My distance from P, my distance from B, okay, from B for P. So it is S equals to S1 plus S2, which is S1 equals to 2.8. Okay, S2 is 3.2. So I want to find out how long, what is the total distance that has been traveled by the P. So SP, it will be 2.8 meters plus 3.2 meters. Means that it has traveled for 6 meters. Alright, so now, when you look at the diagram, means now, okay, I have not enough space, so I show it on next page. Means now, okay, let's say this is the diagram. The P has traveled for 6 meters. This is a B, this is a C. Here is 6 meters. Means that your P reaches here. Okay, and when the combined particles goes down to C, this is your F, which means here still have 1 meter. Alright, so now I need to find out when these two collide, it will travel for how long, how much distance it will collide. Okay, so what to do is, when they collide, SP equals to 40 because the VP is 4. Okay, then SQR, this is a combined particle, it will be 2T because the V is 2. When you refer back, here is the 2. Alright, the combined velocity or speed is 2. So now here is 2, VQR is 2. So from here, right, I know that the total of these two distances is going to be 1 meter. Here is 1 meter. Right, this is a SP. This is your SQR. So SP plus SQR is going to be 1. Therefore, 40 plus 2T is 1. 60 is 1, which means at another 1/6 seconds, they will collide. Okay, so now I need to find the distance. So SP is going to be 4 times 1/6, which is 2/3. Okay, then now the total distance, alright, total distance from from B at which P collides with the combined angle, combined particle will be the SP plus the new S here. Okay, so total distance from B at or when P collides with the combined particle equals to the distance that we have found just now, 6 meters. So 6 meters plus 2/3 meters, which means you are getting 6 and 2/3 meters. So that's the solution for this question. Okay, and this is the last question. So thanks for watching this video. Please subscribe to my channel and stay tuned for more upcoming videos. Okay, thank you. Bye.